Hey everyone, welcome back to my channel EduVibe. Today we will start with another topic of the forces and fields, which is the current carrying wire in a magnetic field. Now we're studying that wire which has the current on it and in the magnetic field, and we have a magnetic field on this. So in this we will learn the last left hand rule, which is 3B. We already learned the 3A left hand rule. Now we're doing the 3B, which is the last, and in that case we are dealing with the current now. So as you all know that, you can see this is a current over there involved in this. So that current is used in now in the that left hand rule. So before starting that the left hand rule 3B, we have to know that what is electric current. So electric current is the charge upon time. As you can see over there, current is something which has the current on it and has a charge per time. So that I knows the electric current in ampere. So SI unit of current is ampere. Q is the charge in coulombs, and time is the T is the time in seconds. So let's quickly do the one example for this. How can we deal with this? To have to remind the current in meter ampere between the two parallel plates. If 2.8 into 10 raised to power 16 electrons flow through the gap in the time of 0.80 seconds. So we have a time involved in this. But we can't have the Q in this. We have, instead of Q, we have a electron, number of electrons we have, which is 2.28 into 10 raised to power 16 electrons. For that, we know that Q is equal to ME, because we know that uh, Q is equal to ME, so that N is 2.8 into 10 raised to power 16 electrons, and E is the elementary charge, which is 1.6 into 10 raised to minus 19 coulombs. When you solve this, you get the Q from here, which is 0.00448 coulombs. So this is your Q and this is your T, and you have to find the current. So I is equal to Q upon T. I is equal to Q is 0.00448 coulombs divided by the time is 0.80 seconds, and you find it out and you get 0.0056 ampere. But you want this in meter ampere. So this m, small m, is the value of 10 raised to power minus 3. So this is your prefix in your prefix sheet, in your prefix list. This is called the milli. So that is equal to this meter divided by the ampere. This is the meter ampere. So we do the meter ampere. That ampere has cancel out from here. And when you solve this, you get I of about 5.6 meter ampere. You have to multiply this. So that's your current. So that's how you can find the current from there. But we can't do like this type of thing anymore. We involve this current into the magnetic field. So this is just the refresh your mind that what is current and how can we use that current in anything. So basically we're doing this new topic in grade 12 physics of this topic. So we're doing the left hand rule 3B. So what's that thing? There's a small modification in this. The rest of all the things is same. So to find the magnetic force on the current carrying wire, we apply the same principle of the third hand rule, which is 3A. Deal with the free charges. Now we deal with the free charges in this main thing in this. So we have some small modification in this. So point your thumb in the direction of the charge movement. So thumb is in the charge movement of that direction of charge electric current where involved along the wire. Then we have a fingers, which has the direction of the magnetic field. That direction has the direction of the magnetic field. The direction of your open palm indicates the magnetic force, or we can say that the speed. So that is about the magnetic force of the anything. So from here we can say that the left hand is for the negative charges and the right hand is for the positive charges. It's the same thing we do in the first hand rule. So that's the thing you have to know in the left hand rule 3B. And that's the one thing more. So we are doing that formula calculating the magnetic field, which is about like QV and in times magnetic field. But when they involve in the carrying wire, current carrying wire, so we're using that formula, which is Fm is equal to current times L magnetic field. So the I is the current in ampere, that L is the length of the current carrying wire in meters. So that's the main thing we involve in this, that length. And then B is the magnetic field strength in Tesla, and that force is the same in the newtons. So that's the formula we have to use now, and we have to find that quotients. We have that quotient involved in this. So we have example in this. So we have one thin conducting wire of 1.2 meter long, has a mass of 0.0060 kgs. So to find the minimum current required to suspend the wire in the magnetic field with the strength of the 0.15 Tesla. So here's that one word called suspend. So if the suspend is suspended, this means our net force is always equal to 0 in that case. So they are involved in something. They have a force in this. So they are the force and they have a gravity. So we have both the things simultaneously. So if the net force is 0, so if your Fm goes over there, or those two upward, your gravity goes down. It's the same like we do in the Milgren's all drop experiment. So same thing we use. So net force is 0. So this means Fm is equal to Fg. But this has now conducting wire. So that's Fm is equal to IL magnetic field is equal to Fg, or you can say it's Mg. So we have to find the current. So current remains over there. We get Mg and divided by L magnetic field. So M we already have 0.0060 kgs. G we all know that is 9.81. This should be in positive. And divided by L we have 1.2 meters. This should be in meters. If it is in centimeters, we have to convert. And we have a magnetic field of 0.15 Tesla. So when you calculate this, you get about the current of 0.33, which is the ampere in that case. So that's how you can use this formula with relation to the magnetic gravitational force formula. So that two relation we have to find, and this has to be 0 if you use that relationship. If not, so the net force is equal to Fm plus Fg will be your formula. For this lesson, so learning by simple with EduVibe, learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. We are left with one topic of this unit, and then we complete that unit, which is the electromagnetic radiation, and we have one law in this. So we'll do that lesson in the next lesson. So see you in the next lesson. Till then, stay connected with EduVibe.